Good afternoon. Welcome to the Kaminario show. Thank you for those of you that are attending. I'm going to cover flash storage. Anyone ever heard of Kaminario before today? Hopefully some of you out in computer land, out on that Internet of Things, is on the line and listening. So as we go through, I don't envy anybody in this world today in the IT space. One of the things that I look at is how constantly things are changing. One of the things that I do is, what would Marty do? If you all remember Marty McFly coming back to the future in October of 2015, it was a pretty exciting year when he came back. He brought some gifts with us and left us back in 2015. Now it's 2016. So as I go through, I'm going to talk about some of them. You know, you look back at in the 60s and 70s, I mean, the mainframe was a primary mechanism for everything that was going on. Compute network and storage all in the same exact data center. Things haven't changed much. We made things a lot faster and smaller and things like that. But when you look at it, you look back at 1964 when the mainframe was first established. You look back at 3745 and 3270 terminals, all these things that most of you don't remember. Unfortunately, I'm a little bit older and I do remember a lot of them. 1972, VMs were invented. When you start and think about VMware, was it the first introduction into VMs? No, it was just the second round or the third round of these technologies. So as we go through and talk about these technologies, what we want to do is just make sure that you understand exactly, this isn't the first rodeo. We all understand exactly what's going to happen, how everything is going to go through from that circulation of the technology. We all have heard about the infamous, in 1981, Bill Gates saying that no one is ever going to need more than 640K of RAM in a box. Now you sit and look at, terabytes of RAM in a lot of these boxes when you start thinking about the factors of change over the years on how we've had to change things. I know when I first started selling disk drives back in 1998, selling 1 gig drives, 4 gig drives, 9 gig drives, when you start to think about how the technology is changing and what has really changed. In fact, in 2000, we had a 15,000 RPM spinning disk drive. That was the fastest. This was a game changer. We went from 10,000 to 15,000. This was, holy cow, these are the things that are going to change the world. That drive is still the fastest drive that we have today from a spinning technology. Yes, we've made advancements, we've made them better, we've made them bigger, but it's still the fastest technology. So when you look at things, we all use flash on a day-to-day basis. Everyone has a phone that has a flash drive in it. Most PCs that we have today have a flash drive in them. How do you utilize them? How do you make sure that we're going to be able to have them around for as long as we need that information around? So as we go through it, 2015 was a pretty exciting year. 3D TLC NAND drives were released. What does that really mean? TLC, triple level cell. Well, when you look at it, the goal here back in 2014, we had flash targeted to get down to $1 a gigabyte. For those of you that saw the flash drives back in the 2006, 2007 timeframe, just to give you, it was around $1,000 a gigabyte. Now you're getting down to $1 a gigabyte. That was the goal. How do you get there? How do you efficiently do that? It came down to a lot of different things. Also, I talked about the 3D TLC. So within the flash drives, there's 3 different tiers of technology. When they first came out, there was SLC. That's where we had that, $1,000 a gigabyte. Then they came out with MLC, multi-leveled cell. And then eventually we came out with triple-level cell. The TLC drives is when it started to become more affordable for our data centers. But again, reliability became one of the biggest factors that we needed. How long can we write to these? What are the right efficiencies? What are the write cycles that we can withstand on a daily basis? So as we go through, I'll talk about some of those things. One of the most interesting things this year at the Flash Memory Summit back in August, Seagate announced a 60 terabyte flash drive. Going to be real in the next couple years. So you look at the technology, how quickly it's advancing, how quickly it's changing. Very interesting. So this is what I look at as your job from an IT perspective every day. How do we maintain technology? How do you know, am I going to buy the right technology at the right time, and is it going to last me? One of the things that I look at when you walk into most data centers, the first thing that you're going to do is you're planning the life end of that product. Because you're already thinking about it when I'm buying it. I know it's going to be 3 to 5 years, so I'm already planning that I need to make a change at that 3 to 5 years. We want to change that methodology. How do you evaluate it? How do you go out and look? And we all say the same exact thing. There's not a lot of difference. We use the same Intel processors, the same flash drives that everyone else uses. It comes back to the core. The software defined, all those different things that we really separate ourselves. When you look at that, how do you really, every marketing material, besides the color, everything else looks pretty similar. How do you really separate it? And that's when you look at the technical resources that we have. These are the people that can take you down to that second layer of questions. What does this really mean? When we say that we can get these ratios or this performance, we need to get down to that next level. The other thing that you are constantly challenged with is how do you do more with less people? You're never going to get, your capacity is at least doubling every 3 years. You don't get more people every year, so how do I manage this much more storage? How do I do all these things? So we're going to cover a lot of that. Troubleshooting. The bottleneck in this industry is constantly being moved around. All those technological leaps that you hear about, Moore's Law, on the processors, on the drives, on the sizes, everything is constantly, we're moving that bottleneck back and forth between different areas every couple years. So how do you understand that? Making that right investment to make sure that we're not being held hostage going into if we buy something today, is it going to hold us there and we have to stay with it for the next 5 to 10 years? So we're going to cover some of those things. Any questions, any comments? So as we go through this, we'll start to touch on a lot of different things. There's obviously a lot of choices that you have. You can put things out in the cloud. Everyone says the cloud is the easiest thing out there, right? It's easy because I let somebody else do it. Put everything out in that cloud and let everyone else manage it. Typically doesn't work that way. What we end up finding is everything is good the first day, but when you need to start recovering, doing other things, there's limitations. You start losing control of some of your aspects of that. You look at hyperconverged. Anyone looking at hyperconverged today? It seems easy. Put it all into one, right? Compute, network, storage into one. Remember that picture that I showed you at the very beginning? Doesn't it look similar to that? We've seen this story a few different times. Why did hyperconverged really come out? I remember Microsoft and VMware coming to us as vendors saying, you're killing us. We can never find the performance issue in your environment because you're taking all these servers, plugging them into this thing called a SAN. And we never know exactly which one is causing all the performance issues. So Microsoft started telling us, segment it off. Buy a SAN for this one, a SAN for this one, a SAN for this one, a SAN for this one. We did that before as well. This is, when you look back, this is how the whole thing started. We had one big mainframe computer with one big DASD, and we let everything in there. Then we went to this world called distributed. It's the same circle of evolution as we go through this. Because of those bottlenecks that we keep on moving around. So as we go through, we talk a little bit about converged. It makes sense. But there's scalability issues. How do I continue to scale? How do I make sure that I'm buying the right capacity for this converged box versus this one? Because what happened in the late 90s, early 2000s is I bought all these boxes, and this one was only 30% utilized. This one was 150% utilized. This one was 80%. I can't take and move those resources around. That was the big challenge that we had. So that's why we created this thing called a SAN. But now we're getting back to that. I talked a little bit about software defined. Software is where we really separate ourselves from everybody else. That's the feature function, that's the brains behind it, that's the usability. The user experience that you're going to get is all software, right? Makes your life easier. That's our number one goal from a vendor standpoint, is give you the tools to make your lives easier so you can do more with less. So as we go through, we'll talk a little bit about that. Then you have those traditional all-flash arrays. This is where I look at taking a system that was built 15 years ago, bolting on a few products, and calling it an all-flash array. That's what they had to do. They had to make sure that they kept all their existing customers happy and doing all these things, so they just made modifications, did some things. What I want to talk to you about is how we did it. We started from the ground up. A brand new system with flash in mind. Ease of use, all these different things. What does it mean when you talk about flash? You look at how elegant from a power consumption standpoint. When you look at it and people really understand the total cost of ownership in the flash space, you have to take into consideration all these different things. Power cooling. Remember the disk drives? They were the only spinning factor in that entire world anymore, drawing a lot of power. So we have to take into power and cooling. You no longer have to worry about those. Higher performance. Everyone has been targeting less than a millisecond. Anyone walks into an application, what's fast? Less than a millisecond. How much less? What's the difference between 200 microseconds and 800 microseconds? Can you tell? Exactly. And when you sit and think about it, what does it really mean? Today, it doesn't mean a big factor, but what it allows us to do is grow and put more onto that so that we have more time with it. So if we're at 200 microseconds and someone else is at 800, as I add more onto this, this gets longer and longer. This takes longer to get there. Interesting concept, right, as we go through it. Easy to manage. When you sit and think about it, everyone should be pretty easy to manage today. If you think about it, how quickly should you be able to manage and create space? Storage is easy. Capacity, map it to a server. I'm done. Start using. That's how easy it is. Same thing. One of the things that became a huge factor in this play is, everyone's been talking about data dedupe. Dedupe and compression. These are the big two factors that what we want to do is we know that you're storing data multiple times. Why should you store it multiple times? If we can go in and check to see if it was the same data, we could only store it once, keep metadata to match it up to the other data. But what happens is on spinning drives, we spent so much time looking to see if it was the same data, we just could never do it in line. So it was a post-processing. After it was already stored, we'd go through and look at it, and it was causing cycles to be spent on processor and all these other things. So we'll talk about some of those things. Less data center real estate. We already talked about the size of the drives. Now you look at a 60 terabyte drive in the next 18 months. 60 terabytes in that amount of space, when now I have, maybe 3-4 racks for 100 terabytes. Now all of a sudden I'm going to have 3U of space taking up hundreds of terabytes. So when you look at that, again, that's power cooling, all the total cost of ownership as you go through it. We already talked about the less cooling, more server consolidation. Because now we can do more with less, you can have those servers do more. We're moving that bottleneck back up to that server environment. It's no longer the spinning drives that are the latency that is killing us in those environments. Any questions, comments? What's the difference in performance? When you start looking at what gets your attention, 10 times the performance, that gets my attention right away. How many times a day do you get a call from one of your users saying, holy cow, your things are working so fast, I can't believe it? Never. They don't call when things go great, they just anticipate it. They think that things are going to get better and better, and the only time that they call is when it's a bad thing. But what if you could give them 10 times that performance? These are the types of things that we see when we put our Kaminario all-flash array in customers' environments are like, holy cow, what did you do? That's the things that change. You look at the operating costs, not only from the manpower, but the ease of use, all the flexibility, no longer having to think about RAID, no longer having to worry about how do I tune and have to match this application to this. Everything just runs very fast. So your operating expenses are reduced. Productivity. Spend your time doing what you like to do. Don't spend your time chasing a performance-related issue. Those are the things that kill you. When you look at it, 75% of the external storage spending will include flash. Everyone believe that? Everyone believe that tape is going to go away? We've been hearing tape is going away for many, many years. It's still there. But I'm guessing spinning drives are going to go away before tape does. You see where the technology is going. You see how fast everything is going there. 100% of the companies will have it somewhere in their environment. It's amazing to think about how close we are to this. Why are we doing it differently than others, and how? Some of the things that you look at, some of the things when you start looking at all-flash arrays, they're going to talk about different things. Scale up, scale out. Everyone understand those two terms? Scale up, I can add capacity. Scale out, I can add compute. When you start looking at that, those are two very important things, because if I can do them independent of one another, and I'm not tied to having to add compute with storage or add storage with compute, it ties you into a very not effective cost model. So as you go through it, we'll talk about that. Efficiencies as you go through. We talked about in the target of 2014, $1 a gig. That was the target that all flash vendors wanted to get there. We're not going to do it by raw space. We're going to do it with compression and dedupe. That's how we're going to go into those environments. How do we get that? Plugging more into us. Not isolating those islands of storage again. We want you to put everything into us. Mixing and matching all the flash and control technology. As quickly as the technology is changing, we need to have that ability to be able to change and add those new technologies in and coexist. We don't want you to spend something that's not going to be here or be available in a year. We want you to be able to mix and match all those technologies. One of the things that we said we were going to concentrate on today here is mixed workload performance. What does that mean? When you look at it, a system is typically designed. If you look at, like in a race world, a system or a race car is designed, for top fuel to just go one shot really fast. That's what that system is built to do. If you ask that same race car to go 500 miles, it's never going to make it. It's designed to go, that 3/4 of a mile or whatever it would be. So when you look at mixed workload, systems were designed to be really good at one workload. We change that dynamic. We automatically assign the block size that is sent down the pipe to the application, and that's what we use within our system. That's what makes us different. So what happens is, no matter what the workload is, if it's OLTP, OLAP, VDI, whatever it is, we perform great in every one of those environments. This is where you start getting into that next layer of questions of the dynamics of why are you different than others? Because we can be adaptive to the block size being sent by the host. We will change from 4K up to 128K. Some of the other factors that you look at, some of the competitors, they have a fixed block architecture that says if I send 128K, I have to break it up into 8K chunks. What does that mean? I have to, every time that 128K comes in, I have to break it up into 8K chunks and keep metadata, all these different factors on everything there. So we'll touch more on that. Leading the industry in scalability, when you sit and look at it, we'll talk about how we scale up and scale out to make sure that we're going to have a system that's going to last you for the rest of your life. No more data migrations, no more thoughts of that. As you scale out, we call it our perpetual array. Perpetually grow that system. When it makes sense, I'm going to expire the older systems, but it's going to be after 7 or 10 years versus the 3 to 5 years that you're originally planning. When it makes sense, expire those technologies. So when you look at it, we talk about predictive cost efficiencies. Again, buying the right flash at the right time. We don't want you to buy 3 years worth. We know technology price curve. Buy what you need today. But the reason that people were buying more is because they hated the thing that I had to go out and expand it, do all this work, and then all that stuff is going on in the background. Make it dynamic. If I add something in, it automatically balances across everything in the system, uses all my resources. Predictable performance. When you look at this, anyone familiar with SPC 1 and 2? These are Storage Performance Council. These are the things that all storage companies were judged at, is how well do you perform in these environments. We went in with one system. Again, a lot of the competitors went in with one system for one test, one for the other. We went in with the same system and we performed great in both workloads. In fact, 2 years ago, we had the #1 place in each one of those tests with the same system. just to show you that. Now, there's others that have built these monster systems out there just to get that lead. We can show you that as well. But resiliency, when you think about it, how often do you like your storage systems to come down? The foundation, the pivot point of your entire IT stack. If that thing goes down for any reason, nothing else works, right? It's kind of the foundational piece of your entire infrastructure. There's no such thing. 100% uptime. We guarantee 5 nines of availability. When you look at those things, I mean, those are things that, again, having that mindset from the very get-go. We talked about the scalability. We understand you need to scale. We understand that you're going to add capacity and add storage every couple years. We want to make sure that we're there with you. Predictable cost. These are the types of things. When we look at the dedupe and compression ratios that we get, we monitor every one of our systems worldwide, and we come back with a very aggressive number and say, we know that we're able to guarantee 3.4 to 1 compression and dedupe ratios. Even though we're getting 5.8, 5.9, we put a guarantee out there that says if we don't get this, we'll supply the storage to you at no cost. That's how comfortable we see in this environment. Again, having the ability, as you go through this, having those technological discussions when you get down to it. Can you turn off dedupe on a volume? When you get into some of these other systems? Those are the questions that you need to have. Because does it make sense in certain environments to have dedupe on? No. Does it make sense for me to have compression on my database, or does it make sense to have compression on my storage? Those are the questions that we'll work with you on to make sure that you're getting your best efficiencies as you go through. Everything I talked about, everything is in line. So as you go through, there's no touching everything. You guys are doing this, everything is going to be there. The other thing that we make it simple, all in one pricing model. There's no, oh geez, you wanted the XM radio module, or you wanted the little this little feature. Those are the things that some of the vendors will come back and kill you on later on. You didn't say that you needed to do this. Everything that you see, everything that you are able to do is included in the system itself from a pricing standpoint. I talked a lot about the predictive performance. We're going to give you the best performance all the way through. Having that capability to do, some of the others, when they built their system, they hurried to market. I can hurry out to market and build something and get it out very quickly, but it might not be the right way to do things. So as you look at some of the competitors, ask them, are your controllers really active? Or you have one sitting there doing nothing, waiting for a failure. So I'm sitting there with a system that's partially being utilized all the time. The other thing that you look at is adaptive block size. I talked about that, switching the block size automatically. You guys don't have to worry about it. No tuning, nothing that you have to do. The system in the background is doing this, matching up to the block size that the application or file system is actually sending to you. Mixed workload processing, this is where you get that guaranteed performance on no matter what you put into there. And then also just keeping track of metadata. I mentioned metadata. It's an in-depth discussion that we can go this deep on, because eventually metadata does come into play. Because if I'm breaking things up into smaller chunks, my metadata is costing me more money. Resiliency, I think we covered. Scalability, we covered. One of the things that we've done is we have become so confident in our system, we came out with this assured program. We guarantee these things to you. So as you're going through capacity, availability, performance, we guarantee them. The sales team will come in and talk to you about them and say, this is what we guarantee. Very aggressive. We're trying to make sure that you understand that we're in this with you together. This is something that we're not going to leave you alone. Same thing with worry-free forever. Not just what we have today, but scale. No more forklift upgrades. Anything that you have today is going to be able to coexist with what's coming down the pike. Like I said, technology is changing very quickly. You'll hear these new technologies, NVMe, you hear Crosspoint, all these things. Where do they fit in my environment later on? That's what we want to make sure that you have that comfort level that what you buy today is going to coexist with what's coming down the pike. The other thing that you look at, who has ever gone through that year 4, year 5 maintenance agreement with your vendors? when they do that uptick. And all of a sudden that forces you to go back and look at something new because it makes more sense. The costs are so great at that point, we want to make sure that we want you to look at that. We change the game. We guarantee as long as you keep that hardware, the costs are going to be the same. In fact, we feel so confident on our flash drives, we actually guaranteed them for the life of the drives. Even though the vendor to us says they're 5-year warranty, we initially extended out to 7, but with all our historical information on all these drives and how we're using them so efficiently and we're using our rights in a very unique way, we actually think these drives are going to last somewhere between 25 and 50 years. I don't know about you, but I got lots of gray hair and I'm not going to be around here for many 50 years. So when you look at it, but we feel comfortable. We're guaranteeing them. Same thing as you go through. Lots of different guarantees that we talked about the perpetual array, and the reason I'm hurrying through a couple of these slides is I got the 5-minute warning. So unfortunately we had a little bit. I'm going to get into the product a little bit. We talked a lot about that. What is the Kaminario product? Consists of hardware, obviously. We have controller nodes that are called K nodes. We have SAS adapters just to connect to the drives themselves. We have fiber channel iSCSI adapters to connect out to the hosts themselves. We have InfiniBand connections just to do the interprocessor communication from the controllers as we scale out to guarantee the performance. Adding shelves behind it, so you have 24 drives per shelf, scaling up to 3 shelves of drives behind a set of K nodes. But as you continue, that's what we call a K block. So that's 1 K block. This can start off, we have, depending on the drives, you can have a 25 terabyte shelf, 50 terabyte shelf, or 100 terabyte shelf, and scale those up independently. So as you go through, I'm just going to do a build out here. So again, that's a single K block. You have all of this information, all these factors in there. But as you start to scale up, if I need to add more processing power, all I'm going to do is add another K block onto that configuration. What does it do? It doubles my IOPS, doubles my bandwidth, maintains a low latency. And when you're talking low latency, you're talking 400 or 500 microseconds up to 600 microseconds in that environment. As you continue to scale, you can scale out to 4K blocks. From a performance standpoint, that's going to give you over 1 million IOPS, over 13 gig of bandwidth. Again, depending on if you're, high throughput environments with a large block or IOs on the small block side. I mean, those factors, it's the same system. It's going to do both of those very elegantly. And then it also gets into that place where now I can scale up and out at the same time. So I can add capacity as well as compute. Again, growing on beyond petabytes of storage, full storage information behind there. Make sense? What do you think? Like it? So again, we're changing the dynamics of the storage world. We're putting our money behind, our confidence in our product. We're going to guarantee all these factors as you go through. We'd love for you to come through and take a closer look at our system. Make sure that you understand exactly what your requirements are. We're going to build the right system for you. We feel that we have built the right architecture from the very get-go, not only to take the advantage of all the flash capabilities, but also understand where the future of the technologies are going and having that coexist. So, we talked a little bit about the forklift upgrades, data migrations, no such thing. As you start scaling out, what you're going to be able to do is look at your costs. I'm going to start with what I need today. Second year, I might just have to add capacity. Third year or fourth year, I need to add some additional performance. Same thing as I go through. Keep that system scaling out. Now what ends up happening is when I get to year end, now I can start, these drives are changing so rapidly. So the system just, imagine it's just growing out. And when I get to the end, I add the next one in and I expire the first one. Just have that capability. So there's no such thing as moving your data ever off of a system again. We want you to make sure that you're doing the things that you like to do. managing applications, doing whatever you wanted to do. Storage is simple. We've tried to simplify it as much as we possibly can. From a GUI perspective, imagine 5 panes of glass for the standard GUI. If you have replication, there's a 6th panel. We can do a knowledge transfer of our UI to you in probably less than 30 minutes. You will be an expert. We'll give you the cross, and you are certified to be able to manage a Kaminario array within 30 minutes. That's how simple it is.